So in the last class we covered it's part B6. Yeah. Once again. In the last class we covered about the subplots, right? So let's go ahead with all those. So it's your TST 7. Right. Okay. So let's learn about the subplot to grid. Okay. So this is a function, subplot to grid function. Okay. So its main work is to give more flexibility in creating an axis object at a specific location of a grid. Okay, so if I write it like that, this function gives more flexibility in creating an axis object at a specific location of the grid. Alright, so it also allows you to give the access object to span across some multiple rows and columns. Alright, so just see if you write the syntax of it. So syntax is kind of plt dot your subplot to grid. Okay, that is your subplot to grid, and then you write down your shape, you write down the locations, and also you write down the row spans, okay, for the row span and the column span. Alright, so what are these things? Right, I'll discuss. So this is a kind of a syntax you can say. So I'll write a code down. Okay, in that I will be using. I'll just writing what I will do that. Let's write the code first. So I'll be creating a 3x3 grid, right? 3 rows, 3 columns. Okay, and with the excess objects varying in the size. So you will see how it happens. So first of all, you have to import the Matplotlib as plt. All right. So let my first will be plt dot the subplot to grid, and let these things to be 3x3 because I need a 3x3 one, and among of these all this is in 0 commas. Okay, so this is my, and I'm writing this is my call span equals to 2. Similarly, let's take a2 subplot to grid. Now let's name it also 3,3 and the place is 0,2, and I'll write it as row span 3. You'll understand when the outcome will come. Row span equals to 2, call span equals to 2. So that's good. Now let's import the NP and just plot the x. We haven't taken the x there, right? So let's make the x as np dot range of 1 to 9. Alright, so let's plot this as x comma x square. And now, since I'm plotting in the grid one, so I'll be using the titles and the plot also. So I'll write set the title, and my title would be set to the square. Okay. Similarly, let's take out the a1 dot plot, and there I'll be writing it as x comma the exponent value of x. Okay. Let's see. Okay. Now this is my a1, this is my a2. Alright. So similarly, like I have plotted the square, I have written the title square. Same I'll be writing for the exponent also. So set title exp. Okay. Similarly, let's take out the third plotting. Let me plot this as the logarithmic values. So x comma np dot log of this x, and then again just set the title. This is log value. Okay. Now this is a tight layout. You'll see what comes there, and this is our show. So you can see. So what I've done is, see. One second. So as you can see now that we have plotted 3 subplots in kind of a grid. Okay. So these are a kind of a grid. Here what we did is, we have in the example here what I have shown you, there is a kind of a 3 cross 3 grid. Okay, there's a 3 cross 3 grid of the figure of the object, which is filled with the access objects, and you can see like the size is varying, right? Like the column spans, each row has some different plottings and all these things. How? So I have plotted this as a 3 comma 3 that I'm having 3 grids. Okay, I'm having 3 by 3 grid, and this is my first one. This is my 0 of 0. Okay, and I've written the call span as 2. Okay, so instead of 2, if I would have written it as 7, so you can see the difference what is coming there. Okay, so that is the difference. I have written as 4. So you can see on that it's not getting fit here, right? It depends. Let's say you have written 5, whereas 4. Okay, fine. So that depends. Let's say it 2. You can see, right? And this row span as my 5, and the row span is 4, and col span is 2. Okay. We'll go on with this more, and you will be able to understand, right? So the grid, how grid works actually. Let's see how grid works. Let's write it as grid. You will see how these grid works. Okay, see. So the grid function particularly sets the visibility of a grid inside a figure to just like for a turn off and a turn on, whatever you do. Okay. So like you can just give the color style, line width, and all those things in the grid. Grid is something like, you know, in the class 1, 2 you started doing mathematics in some box copies, like similarly like that, right? So let's give some grid. Okay, so for that, okay, we have imported Matplotlib and NumPy. So directly giving the figures, comma the axis equals to plt dot the subplots, and write is 1 3, and the pitch size equals, let it be 12 comma 4. Okay, now you know what are fixed size and all these things. So let's make it as an range. Now again the same thing, the axis of 0 to plot x comma x cube, and we'll be giving the g. Okay, you get to understand what I have done there. What is this LW? Line width is the LW. Okay. So I'm plotting. Understand the first line. What I've did, I've said that I'll be plotting a figure of x's sum of the subplots 1 to 3. Okay. Now that means that I'm plotting 3 graphs there, right? And figure size is 12 by 4, right? 12 inches and 4 inches there across. So x is an NP range of 1 to 10 the numbers. So the first plotting will be between the x and x cube. The green color will be coming there on the graph, and I want the graph, the line width of the graph to be 2. Understood? Similarly, I'll be plotting 0 and I'll be writing that there should be a grid, that is true. Okay, so there should be a grid. That's all. Next, I'm writing x is now 1 and again plotting it, and this one to be the versus the x versus a np dot exp of x. And here let's give it as a red color. Okay. And also here let's write the axis 0 and just set the title. So title would be kind of a default grid. Okay, by default it is how it looks like, right? So this is a red, and again the axis of 1 dot the grid. Now let's modify our grid, right? So let's say that the grid color should be blue, right? Grid color. There should be some line style. So line style would be a -1. Okay, and let's take the line width. So let's take it 0.25. So this is a modified grid now. Okay, and now let's write xs1 dot set title, and say that it's a custom grid. Okay. Similarly, let's write axis of 2, set the title, no grid. Okay, this is without the grid one. Now after the, let this plot first. So x versus x. So it's no grid, so I'm not writing any grid or anything else, right? And the last, just give it as the figure as a tight layout. So you can see default grid, the custom grid, and without the grid. Okay. This is just a C, right? We have just plotted it there, x versus x cube, and that is a default grid. So this is a default grid value. Then you can modify this blue color and the line size, line width, and all these things, right? Then this is no grid and nothing is there, right? So that depends how you write your programs, right? Now, how to format this XS? So we'll now see how to format the axis. See, so sometimes one or few points are much larger than a bulk of a data, right? So in such a case, the scale of axis needs to be set as the logarithmic values or rather than the normal scales. Okay, so the log scale, particularly in the Matplotlib, is used for the x scale, v scale, and all those things. So we'll learn how to write these things. Okay, so it is also required sometimes to show the additional distance between the axis numbers or the axis labels, right? So that can be represented by the x and y. Okay, so both the features of the x and y are very demonstrated while writing a program there. You can see, right? So let's again define the figure and the axis, and let it be again the subplots. So I'll be plotting just two of the graph now, and the fixed size I'll take it as. So my fixed size would be, let's say, 10 by 4. Nothing here, here. Okay, so this would be my fixed size, right? So let's like take x equals to np dot a range of 1 cross 5, and just taking a copy of this one from here. So I'm plotting 2. Okay, I'm plotting this 1 and 2, so I'll be taking it from the here. So we'll do some of the changes. So in place of these things, right, for the plotting here, I'll write x versus np of exp and of x. Okay, so x versus the np of exponent of x, and here the plotting would be, this is not present. Okay, it's better if I take it the first one there. So there I'll just write it as excess of 0 and plot of x square. Okay, and then we'll just set the title to be the normal scale. Okay, so this is for the first plotting. Similarly, let's take the second plot. Let's write it excess of 1 . So let's write excess of 1 as, okay, let's remove these things. So let's plot as x versus the x square gain. X-axis be the normal scale. Once again, so 0, 0 is to be minus 1. Plotting of the number of exponents by the 2. Okay. Fine. So let's write it as 1 dot set y label dot. Please give us Okay, I think some error will come. No, fine. So see what happened here. If you see the graph carefully, what is happening, you will come to understand is that I have plotted some figures in the axis of some two figures, right? Some by 10 by 4 or that, right? It's 10 and it's 4. Okay. So now what I have done is the x equals to np dot range of 1 to 5. Okay, so I have taken some x values as 1 to 5. I plotted the x versus the exponential value of the x in the 0. That is your, you can see the exponential values here. If you see the exponential graph, how it looks like. So if you see the exponential graph, this is something like that. So you can consider that this is a kind of your exponential graph, right? And same, I have plotted the x multiplied the x square. This is, you can say, for the x multiplied by x square going on, right? So this was my first graph with the normal scale, right? And I said the second one as the same, the exponential value. Okay, so the next one also as the exponential value as my axis, and I have plotted it there the x versus x by 2. Okay, same values. But I said that the y scale should be a log scale. Okay, in fact, of all these things, what I did, I set this as a log scale, and so the just the varies you can see, right? You can see the normal scale and the logarithmic scale, but the values are same, right? So this is how you looks like. You just write on y scale, that is, I have set the logarithmic scale for that. That is my y scale to be. I can set this for the x also. It depends on what you write. So it's a log scale, so it's looking like 10 to the power of 0, 10 to the power of 1. You can see, right? Okay, and the title is logarithmic scale of y. Okay, so that's it there, y label. And I set the x label, y label of the first graph, and for the second graph x label and y label, and so on, right? So this was the just a kind of the use of the format axis. You can format the axes. Okay, so axis spines are linked with the tick marks. So now what are tick marks? These are the tick marks: 1, 1.2, 2, 1. These are things. You can also define what you want in place of the tick marks, right? You can define what color you want, where which color you want. You want this color has to be red, this has to be blue, axis color to be the red, and all these things. So that can be formatted. Let me show you that. If I write figure equals to plt dot figure. Okay, and let me write it as ax equals to fig dot add the axis now. Okay. Now these things come only when you practice and practice. So again, I'm setting my box types, right? Remember what we did, the same contents. The previous class did 0, 0, 1, 1 to my the box, line width, line, the height, width, and size of xy, right? So let's say the spines. Okay, so axis spines are the lines which connecting the axis tick marks. Okay, so I'll write whether the axis spines there. So let me write it here only. Otherwise, what I say that axis spines are the lines connecting axis tick marks, estimating boundaries of the plot area. Okay. Okay. So the objects have some spines, right? So let's plot that the axis of the spines of so there are four kind: bottom, top, left, and right. So the bottom, I'm saying set the color of the bottom one as blue. Okay, set this as blue, right? And then I said the spines of the left to set the color as the red. Similarly for the top, let's say the left to be set the line width, and that is 2. The same as the top. Let's set the color to be nothing. Okay, so no colors in the top one. And also let's just set it to be the same as for the right one also. Let's say right, and set the color to be none. Okay, now these are the colors I have mentioned there, the line width and all these things. Okay, now I'm saying just the plot, not PLT, just plot the axis and plot it as a kind of 1, 2, 3, 4, 5. So I'm plotting the axis 1, 2, 3, 4, 5. Okay, so that's it for my y. Basically, the plotting you will be doing. So that comes here, and you can see that the formatting you can see, right. So we are having blue color as our the bottom one. That is my blue, right. We have set the plot 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 has been plotted here. That is 1, 2, 3, 4, and the 5 has been plotted, right. Similarly, the top I have said to be no color. So if I write it as free, so you can see a green color there, right. Okay. In the right side, I haven't said any of the thing to be there, so it's not right anything there. So let's say for the left, I have written the line width to be 2. So I can set any line width for the this one, anyone you can set on, right. So you can, depends on you what you write. Okay, again. And then you just choose the left color to be the red and so on. This is kind of a formatting you do in your axis, right. So you can set your limits too inside your axis. You can set your limits, that is called as x limit, y limit, x lim, and all those things, right. So let's say that if I write it as setting limits, right. So setting limits can be done using two of the methods. What it says as x limit and the y limit. So these are two of the methods with which you can set your limits of the graph, that is x lim and y lim. So you write it as set underscore of x lim and set underscore of y lim. This is the kind you write. So let's say for right, let's take it as a figure, and you want to plot a figure. And let's say this is A1, and you are adding some axis, and these are 0, 0. I always take it like that, 1 and 1. Now we'll import the, okay, we have imported, no worry. So let's take x to be the range of numbers from 1 to 9, and then the plotting, not plot, it's plot. So we'll plot the x versus the exponential value of the particular x, okay. And this is the exponential value graph, and then we'll just set on the title, that it is a kind of exp, and we'll just show you that how it looks like. So this is a graph of something you look like, right. So this is kind of thing, exp, exponent value of these x versus the x, okay. Now we format the limits to the x-axis from 0 to 10. Okay, now we want the limits to be from, in place of 1 to 9, we want from 0 to 10. And in the y, in place of 8,000, we want from, let's say 0 to 10,000. So we'll make some formatting now. So just take the above copy of the code, and we'll make some of the changes. Now let's say I'm plotting this as a green color. I'll make some changes, like kind of I just want to set the x limit, and that would be from 0 to 10 as I said, and similarly I want to change the y limit, and that I want to do from 0 to 10,000. That's all, and that should be changing limits. So xs is having, oh sorry, so you can see the change in the limits, right? You can see the change in the limits now. It has came from 0 to 10,000, and this one from 0 to 10 as compared to your values. You can see now, right? So these are the kind of the changing in your patterns of. Similarly, you can also change these things like 2, 4, 6, and 8. All these are called as your ticks, right? So you can also change the ticks value or the ticks labels. So let's write it as setting your ticks and ticks labels. Okay. So there you just change it with the use of xticks and yticks. That's all. So there, these things are used to just carry on the things. Okay. So let's take the syntax is kind of ax set, and then you write, let's say 2, 4, 6, 8, and 10. Okay. So if the elements in the list denote these points of the corresponding data. Okay. So this method will mark the data points here as a 2, 4, 6, 8, and 10 like that. Okay. Similarly, you can just write on. Okay, there are much more methods also. Similarly, you can just write on like set your x labels, or you can write set your y labels. Okay. So there also you can write it as ax dot set your labels, x labels, and that can be you can, depends on you what you write. Let's say write 2, 4, 6, 8, and 10. Your x labels should be 2, 4, 6, and 8. So it depends if you write like that. If you write it as, let's say 2, 4, 6, 8, 10, right? So like that. Okay. Let's plot something and you'll get to understand it. So I need to import a module called as math here. Now let's see, I am writing x to be the some range of starting from 0 and will go to the in the intervals of 0.5. Okay, so it's starting a range from 0 into the maths pi into the 2, or that is your pi, and then it's in the interval of 0.5. Now let's say that we are plotting a figure, and then the same things, right? Let's change some of the values. Okay, so that can be any value you take according to you. Okay. Now let's say set x label. No, not there. Okay. So after plotting, let's say that I want to set the x label as to be the angles. Okay. and let's say set this title to this is a sine graph. Alright, text has let's set the text to, so text could be the same as my 0, 2, 4 and 6. Alright, and this would be my labels, X labels. These to be my labels there. Tick labels, okay. Not my labels, my tick labels. And let's say that y ticks I want to be like -1, 1, 0 and 1, like for the -1, 0 and the 1. Okay. So if I print this one, you will see a graph there, and there is a your ticks in the line number 9. So it is X ticks. So you can see what happens. The X ticks are 0, 1, 2, 3, 4, 5, 6 and all these things are there, right? So what I'll do is I'll just print it like that. So now you can see that the graph is having the labels of the text values as your 1, 2, 4, 6 and 8 instead of everything, and you can see the y label, or y, you can say the y my parameter, that is a y tick, right? So you can see these things. Right? Similarly, we can go with the twin axis. So what's the time? You have a test today, okay, from 1 p.m. Twin axis. So see what it does. This is considered as the useful to have a dual x or y axis, you can say. Okay. So moreover when you plot some curves, right? So you use this plotting called as some twin axis. So how it will help you? Let me show you that. So again, let's take some of the points. Okay, I think I should copy these things. So let it be and plotted by the let's plot it with the exponentiation, it should be of x. Set the title, set it to be a twin axis graph. Now set the y label, the exponent, and this a1. Okay, that is good. So let's take it as a twin the x value. Okay. And what to do more? Set the y label of the x2, which is your twin one. Let's say this as the labels of the logarithmic plan. say log of R O minus, and let's print some of the legend. The labels would be the exponent and the log. Let's make the location of the legend, let's say it in the upper left corner, and let's show it. So let me check it once I've done a range. I've just plotted the x, the title of the, alright, then the twin of x, then a2, and label, then the legends and all these, and even plotted. So what you can see is a twin axis graph has been plotted on. So this is a side of x. What you can see is in the blue lines, particularly there, it will be plotted as green. Let's say so. This looks good. So you can see that your this green graph is nothing but the exponential value of the x. Okay, and this red graph is nothing but the logarithmic value of the x. But in the same graph, you can see the values as a twin one, right? As just a copy, you can say of all. So this is the logarithmic value, and this is the exponential value. You can see the labels there, the y label and all. So you can see both sides the labels coming, and the legend is there in the upper left. Okay, so this is the type of just a twin axis. Alright, so your okay, fine. So we have seen bar plot and we have seen all these things now. Still, nothing. It's more left for discussing, right? So histogram and all those things. Let's see. It's quick, very in a very quick way. Okay. So in a histogram, what comes? We'll end our Matplotlib today. We'll give you some of the questions. So Matplotlib test will be tomorrow. Okay. Today you'll be having a basic Python test, and we'll give you also some of the questions from the Matplotlib to just write on. Okay. So let's say I want to plot a histogram. So a histogram is an accurate representation of a distribution of a numerical data, right? So like you say, it's an estimate of a probability distribution where we use some of the bins. So there where you using the bins, so there my bin, sorry, I'll be using bins there. So bins will be the range of values. Alright, so my bins would be the range of my values. Okay, so to construct a histogram you need some three process. Okay, so what are the three process? You need to divide the bin first. Okay, sorry, you need to write the bins, then you need to divide the entire range in the values of some intervals, and then you just plot it there, right? So we can plot it very easy way, in a very easy way. How to plot it? Like, let's say we want to plot a histogram, and let's say it's figure dot in axis. Okay, and it's kind of a subplot, and you're saying that it's a subplot of some 1 plus 1, right? Some 1 plus, let it be a single 1. Now let's take an array, and that could be having some values, right? So let's say it is having 22, 87, 5, 43, 56, 55, 76, let's say 54, 11, 20, 51, 79, 5, 27, and such of the values, right? So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 22, 87, 523 and all these things, right? And let's give a histogram there. And declare your bins. So your bins would be kind of 0, then 25, then 30, then it depends. You will just take it for 75, and then for hundreds. Okay, this is my bin. So I'll set my title and I'll write it as an histogram. Now, since we know the settings of the x and all these, so I'll set it as 0, 25, 50, 75, the similar way as I've given my bins, right? And I'll set the y label. So y label would be the, let's say, number of students. So the x label would be their marks. Alright, and just let's show, let's see any error comes. So figure with the illegal addresses. Okay, some of values might be less. So let's give it's 543, 56. Let it be here 73. Give some of the points. 55, 54, 11, 20, 51. Still having errors. Alright, so you can see a marks category and a histogram there, right? So you can plot a very easy way, like for the PLT dot hist, and that's all. PLT dot hist and x versus. So there it come like in just a histogram and things you can just write. So this is just a x value and the logarithmic value of x, and you can just plot it. Okay, so your Matplotlib just comes an end to this class now. Alright, so this is your Matplotlib, and this is how you just deal with the plottings in your histograms and all these things. Okay, now I'll be giving you some of the questions to just work on. Okay. So, and yeah, saving a figure is like whatever I said, that is plt.savefig, and you will be saved inside that. And there you have PDF format, you have PNG format, you have EPS, you have JPG format, and like many formats there to just store on the your figures, right? Sorry. So now I'll give you some of the questions. Alright. So there will be some short questions, there will be some practical questions, and a lot of things there. Let's say, alright, so here comes of your ending of the Matplotlib. I'll just download this one. And today is your just kind of Python basics test. Today we have taken some tests of the students in the Python one. So you'll be also giving some basic tests there. Let me stop the video.